data at once. So it actually does go pretty quick. I'm in the blue section. The whole idea about phase 3 is to see where the stuff overlaps. Red and blue are two different lines.
No.
I see noise on the outer edge of the green. So this is where phase 3 really takes, has the ability to clean up a lot more data. You can see if things are agreeing with each other or not.
What do you want to do? Same this one? Yeah, here. Profile window. You do profile window. Profile. Yeah.
You notice that there's a dredge channel, there's some dredge spoil out here. So the graphics in phase 3 is really nice. It's sun illuminated. You can use the hand and rotate it either on a plane or select this icon. You can move it up and down. Zoom in, zoom out. Page up is your vertical exaggeration. And then right click, light control. Allows you to change some of the lighting.
You want to rotate?
Oh, yeah, no. How many? The only way that I know how to rotate it, there's all this. If I go, if I take cut by profile, the white line now goes this way, but you're not rotating the whole thing. So the only way I know how to rotate it is to get to 2012.
What?
Oh yeah, that's
Change.
the only way I know
Rotate.
how to rotate it.
Rotate.
Now it-
Rotate. 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 Here, here, here. Hand.
So, we have to go into our editor.
How are you rotating?
Our matrix editor.
Use the light.
We build our own matrix around.
Use hand.
Yeah.
Hand.
Build our own matrix.
Hand.
So that's fine. And we'll call it a 1 by 1. Okay. Go back to MD Max. And when we enter phase 3, it says auto cell size or auto. We're not going to do the auto size. Where they don't. What do you remember?
Maximum one cannot say. Maximum.
Go to M9.
Straight cut. Straight.
Maybe it's maximum.
M9.
Yeah.
High file.
Cut. Profile by cut.
Maybe it's
And if you're using auto cell, we're going to use the high pack matrix file.
correct.
When you say okay, it says which matrix file you want. This
This
one.
rotate can
This is why you can rotate it. One, because this is correct to this. And it
And
should
take
be able
number
to-
2.
360.
Here. Take by column.
You might just rotate it without going through all this.
He only make a long pack. So he cannot locate using a 3D function.
the only way I know how to do it. So, place another 30 seconds. So we're saving this data, or we're projecting out the bad data points. We can see it. We're going to save it 3 ways. We're going to save 3 files out of this data set. Don't worry about it if you're not done. There'll be some points left over. But we're going to save it as an HS2, XYZ, and a matrix file, just so we have all 3. So file saved as an HS2 file. We say OK. File saved XYZ at XYZ format. Now in this case, it's only 4 lines. Let's not do 1 point per cell. Let's save every point, just for the sake of saving every point. So I'm going to say no reduction. So 4 lines, all data. Finally, I'm going to save the matrix file. Remember, the matrix is going to inherit the 1 by 1 grid, and in the shell, it will export out 1 by 1 sound.
What's in file?
So the 1,
4
2, 3, 4, the
lines.
5th icon
4?
over,
4 lines. Oh,
matrix of 4 lines.
Matrix of 4 lines. Matrix
And I saved 3 different files. All the data points, matrix, and HS2s. File saved. When I did XYZ, I did not do any reduction. I just said no reduction.
Matrix 4 line.
You select to the XYZ. XYZ.
Matrix 4 line.
matrix
4 line.
4 line.
Okay.
And then put one like 4 lines, something like it. Yeah.
Matrix 4 line.
Just out of curiosity, I want to see how big that file was. When we're looking, a couple of megabytes, 100 megabytes. Is that right? 100,000 kilobytes, 100 megabytes. For that XYZ file for all the data points. If I also saved it as XYZ 1 point per cell, and said the average, 4 lines at 1 point per cell. Six megabytes. So you can see why you don't want to save all the soundings, because trying to move this file through tin model, through sort, is going to take a long time. A 1 by 1 is a very good grid. There's a lot of factors that go in when you finally grid the data. You have your GPS uncertainty, you have all your offsets uncertainties and everything else. So 1 by 1 kind of takes into account. We have all the data points, so the separation between each sounding is going to be 5 centimeters. Your GPS uncertainty is 50 centimeters. So you're saving points that you really don't know the precise location. That's why at the end of NB Max, you usually do the 1 point per cell. Trying to take in 100 megabyte into cloud, to tin model, going to slow down the program a lot. So I want you to save it both ways. So file saved both with reduction and then without the reduction. When you do the reduction, go ahead and choose average. Or if you want minimum, maximum, range, median, I usually use average. And lastly, I saved on this icon up here the matrix file. Because what we do with the matrix file, to go from sounding data. That's what I saved as my matrix file. At any point, I could right-click and export out XYZ. So the matrix was a 1 by 1. I forgot to save XYZ. I could right-click on the matrix and save it as as a 1 by 1. I don't like the colors of the matrix. Change the colors. So it's a working file. But the nice thing is, tin model, cloud, they can all handle this matrix file. If at any point I want XYZs, I can get it out. Okay, so we save those 4 files: XYZ, reduction, no reduction, HS2s, and the matrix.
Matrix. Matrix. Reduction. No reduction.
I'm looking for and under view, sorry, under tools, there's this MB Max configuration, custom edit folder. So when we save these HS2s, they kept overwriting the existing HS2s. So if you wanted to process the data and somebody else wanted to process the data, but not overwrite, we can force it into any directory there is. That's somewhat new. That somebody had asked for it. It should have been done a long time ago. Okay, so we have our 4 files. When I exit out of MB Max, the shell opens up, because we really never close it down. Notice what happens. The lines automatically get populated in the shell. I don't have to right-click and say File, Add a file. So, 4 lines, all data points. It's just trying to read it. Eventually, it's going to get in there. Once you're in this mode, when it's trying to read this file, it's going to take a while. There's no really escape key. You could zoom in, try to get a few points. I'll zoom in right there. Right click, set color, make it a red one, and show the other one. So we can see that all these are swaths of data. We can certainly carry them through all these programs, but it's an awful lot of data. The 1 by 1 might be the best representation. It might be off here and there by a tenth. But certainly, we can do a lot more with it, 8.9, 8.9. So I'm guessing it's either spot on or within a tenth of a meter, just because it's a rounding. And that's why we typically don't save all sounding points, especially with multibeam. It's just too much data. I hate to zoom out, it takes forever to draw. But all data points, we uncheck that one, and then zoom out. So this is 1 point per cell. We still can't plot this out. And this is where we're going to start sorting the data. So everyone get into the shell, highlight the 4 lines. You don't even have to highlight it, but notice that we're going to have the 4 lines at 1 point per cell. If you exited out of MB Max and didn't save it, simply go to the matrix file and right-click on the matrix file and save that to XYZ from matrix file. Once in a while, if you get to populate it, because it's an internal program, if you have to, simply right-click on it, add file from matrix, and there's my soundings from my matrix. So there's either way I can get the data from the matrix file, but data from the cell, right-click, set color, blue. And gotta be exactly the same. Well, I'm off by a tenth of that, but the whole idea is that this matrix file, again, there could be some rounding going on with significant digit. Settings, sounding, resolution, I can change it to 2, no truncation. So 736 and 739, so the matrix is doing something in terms of saving. One could be an averaging. So it might be a little bit of a difference, and I'm sure if I dig into it enough, I can tell you exactly what the difference. But so we have these XYZ files. And we have to plot this data out. But before we plot it, before we make a plotting sheet, we need to sort it out. So processing, sounding selection, sort. If you got to this far, do the same thing that I'm doing. Go into the sort program. And see if you can do the same sort that I am. Remember the inherited project, if it's turned on, it's going to be turned on in the sort. If not, just right click on it and enable it. If it's not on, right click, enable. Now I'll put it back to 70. I'll keep it at 25. Select the file name, sort 25 of 4 lines. There's no limit to what you can write here. I think there might be 255 characters, but spell it out enough that you understand what the files are going to be doing. A little bit of sort. So 275,000 points. We might save 500, 600, 422. A little bit better. I don't have a 1. I have a 5.7 and a 10, which is probably clean data. We'll say okay. As soon as I exit out, watch what happens on my listing up there. It populates it. There's my sorted data. We got some noise over there. And to prove that these are the exact soundings, if I show for all the lines, all the points, this sounding 5.46 will be an exact sounding from the data set. Right there. I'm off by about half a meter. I'm off by because there's the actual sounding 546. There's a half a meter or 40 centimeter shift. Again, it could be how I gridded the data. No, because it's a sort. I'm not sure why it should be on top of each other. I'm off by 40 centimeters, and that part I can't figure out. See if there's another sounding. 895. Yeah, 30 centimeters. I'm not quite sure why that's happening, but these are all the soundings. This is picked up by that sort program. It does a really good job, and it's a representation of the bottom. And this is something that we can go ahead and plot, or we can start with our plotting sheet with this as a sorted data set. And that's a smooth sheet. If 25 is too small, no big deal. We go back into processing, sounding selection, sort. Maybe I'll put in 75. Inheritance project, I want to make sure I have the right one. 4 lines, 1 point per cell. going to do it one more time. Because I did 4 lines, the 1 point per cell. I'm also going to do 4 lines, all the data points. To show you that you're not buying yourself a lot by carrying all this data all the time. At some point, we want to read the data. Turn this one off. Enable. Sort 75 all data. This might take a few extra seconds because it's going to be millions of points instead of just hundreds of thousands of points. But if it works right, the output, it should have the same number of outputs because you're always going to preserve at 75. 57 points. I forgot to see how many were the other ones. So some of them are going to be on top. Once in a while, there's a little deviation out. I can't, I'll be honest, I'll tell you why. But the idea is that we gridded the data, so we're looking at a little bit different of the data point. So it's not that we can't use all the data points. It might be just a little bit quicker to just use a gridded data set. And this would be at 75. And this would be at 25. I guess the next step is how we want to plot the data. But for an exercise, I want everyone to run through sort once, take those 4 lines, and see if you can come up with a similar thing. Down selection sort. Go ahead and add the 4 lines of data. Create the radius of 75, select the file name, and sort the data.
His process.
Sort. Sort selection. Sort. What's data? All this data.
No big deal.
Why you do so fast?
Did you save it in
Okay.
did you save the HS2? You saved HS2s or matrix files?
Yes, that. SPL open. Save. Save data.
No big deal. Let's do it one more time.
Yeah.
Let's see where it is. Oh, there it is. All right. File.
File.
Save. XYZ, 1 point per cell, average. And then we say 4 lines.
Out 4 lines.